What I want to do is show you of this quick bang together repeater. Anyone can do this if you got a rough basic knowledge how it all works. And yeah, it's not rocket science. It's just all about preparation and getting your shit together and working out where you need to go from there onwards. So that's what's happened here. And you can use this if we're going closer now. We can use this repeater for any mobile application, or you can have it permanently fixed on a repeater site somewhere up on the tower on the top of a hill, or wherever that might be, somewhere on the hill. But it's portable, kind of portable, providing you got a decent battery to run all this equipment, and maybe a solar panel, or maybe not. If you're just banging it up somewhere for about half a day or a day and you just want quick communications function as full potential. But yeah, you can definitely get this out of this system, what we got here banging together today. Alright, now we're gonna focus on talking about these particular radios at the moment. And as you can see on the radio, it's exactly what it's written there. Well, not actually quite exactly what's written there, but you get the drift. This one is the receive radio. This is the transmit radio. This one receives, this one transmits. And then two radios linked together, two mobile radios. So these are old Motorola GM 339 series and the GM 338 LS series. Now if you got any of these radios, you can link them together and then you hook it up to a repeater controller, and then you hook these up to a cavity like you see there. And what a cavity is, or it's designed to do, you probably already know, maybe you don't, but I'll tell you anyway. A cavity is designed to filtrate the signal, get the maximum performance out of the signal, and separate the two signals from one another so there's no interference, and does all this at the same time as it's coming out at a 1 feed line from the antenna. So as you can see, that's the antenna port, and the signal comes in, the repeater keys up straight away and does this all simultaneously at the same time. If you're buying these kind of cavities, you better off buying them brand new, because some of these second-hand ones come up, they're used and abused, they've been thrashed and they're shit, and usually they got corrosion on those jumpers there where the cavity is. So it depends where the cavity and what environment's come out of. If it's come out of a moist environment, more likely, you know, the cavity's going to need a good workover or service or probably rebuilt. But in this case, you don't worry about that. You'd be better off buying a brand new cavity. That way everything's all new. You don't have to replace any components. You don't have to fuck around. You don't have to do anything. It's all new stuff. When it comes to cavities, cavity filters, duplexes, same sort of shit. Yeah, if you can buy it new, you can get a decent price, go for it. If you don't have the luxury to buy it brand new, or you can't afford it, or you're trying to build on the budget repeater, there's some shit you can bang together. There's nothing wrong with buying second-hand cavities, but just be cautious. Make sure, you know, the cavity's not fucked, or, you know, or any occurring problems you might have later on down the track if it's, you know, been beaten up or in a rough environment, or the cavity's not as good as like it used to be. But that's the problem when you buy second-hand cavities. But I'm not saying second-hand cavities are good. They can be very good, but it all comes down to who you're buying it from and what the condition is, and that's all it is. But with every cavity, if you buy it second-hand and you got a particular frequency in mind, you gotta definitely get retuned. The right test equipment to tune it. You can do it yourself, why not do it yourself? If not, you'd be more likely 9 out of 10 taking to someone. They'll tune it to the frequency you want it on. The cavity will be tuned to its maximum performance, and away you go. And the next thing you got to do is configure the radios, tune them, because as you can see, you got your up link and your down link, and then that all means nothing till you put these two radios into a controller. Can relay the configuration into a repeater control. What makes it is a repeater. So I know what you're thinking. These are just two standard mobile radios being put together and being wired up, and now these two radios are no longer standard radios anymore. They are programmed, wired up into a repeater controller, and we'll get to the repeater control in a moment. But pretty much what a repeater control is, if you're not sure what it does, it just relays two radios on the two different frequencies at the same time, and then allows voice audio traffic to come in and out and transmit at the same time. But now we'll get to the controller. So that's what I was talking about before. That's your receive end. That's the receive. Goes to the low pass on the cavity. Your transmit end goes on the high pass of the cavity, and it's all how you set the frequency up too. So make sure you get that. That's very important, you get that right. So make sure your frequency is correct with the radio, and then vice versa, receive and transmit radio is all the same, and you have no problems. This system should work flawlessly, no problems, providing you don't use RG58 coax, because RG58 coax in my eyes is a pile of shit. And I just set up, you're probably thinking, why the fuck are you using RG58 coax? Well, the reason why I'm using RG58 coax because at the moment it's not going on any site, and this is for demonstration purposes. But if you're going to use decent coax, make sure you use LMR 400 or RG8X or RG400. If you're wondering what this is just a real basic, run of the mill, nothing real exciting. We can zoom into it, and it's a Ham Geek repeater controller. It's got a voice board there on the end of it, so you can voice announcements. You can set that up in the PuTTY software comes with it. You got download, but yeah, what can I say? And this one here is your programming port from here. You just plug the USB programming cable into it, into the computer, and yeah, you just program it from there. But it's a real basic, simple, easy setup. If you're using this controller, like I said, it's not real sophisticated, it's not complicated. It's really, really basic, and it does a job for this application right here. So what we'll do is we'll quickly jump over to here. Now I'll sit back down so I get a better view of what's actually fucking going on here. And now you've seen it. So I'm going to key up on this here, handheld radio. And as you can see, this will go for the repeater, and this one here is just a normal radio. This is not a repeater, it's not configured to anything, it's just a normal regular radio, Motorola radio, and this will receive the repeater signal, same as this when I key up like this. But anyway, you'll see the demonstration now. Test 1 2 3 4 5. And as you can see with this particular Motorola radio, the radio on the left, the red indicator blinking saying it's receiving a signal, and the one on the right is solid red because it's, as you can see, it's transmitting. So it's not bad. This is how it works. This is a quick rundown of it. I call this a shitbox build on a budget, whatever you want to call it. It's just a bang together repeater to show you, to give you a demonstration of how it all roughly works, so that way you can see a visual how it all works. Now we'll come across from here, and you'll see how much power this thing's actually pumping out. So the power on this could be a whole lot better, because once again, it's the coax is letting it down, because RG58 coax is shit. I'll say it again, it's shit. You'll get loss out of this cable, you'll get loss out of this cable, and you'll especially get loss out of the antenna side, because the antenna side's receiving the signal and transmitting the signal at the same time as it comes out of the cavity. So there is loss, but the only way to improve the loss is use better coax, better quality coax, thicker grade. If you can use, LMR 400 Superflex coax, you'd be better off. So anyway, that's the repeater there. It's going to be a little bit feedbacky, but we'll key up on it. Yeah, just like I thought. Test, 1, 2, 3, 4, 5. And another thing before I end this video, how I set this repeater up. So you can have it multiple different ways how you want to set it up, but when I program this one here, I set this up on receiving narrow band, so 12.5 kilohertz. So if you got a radio is receiving or transmitting on 12.5 kilohertz, that's wonderful, that's great. You can transmit on wideband. Sometimes, depending what model or make a radio, the audio might sound a bit strange, a bit muffled, a bit funky, whatever you want to call it, but you'll still do the job and transmit. But this is on the receive side, 12.5. You can set the both of them on 12.5 on the audio side, on the configuration. But that's very important how you set it up, because how it receives, how it's going to transmit, that's how you're going to hear the repeater when it comes in from the audio side. So this one's, like I said, 12.5. This one here, I set here to 25 kilohertz. So you can configure it however you want it, or if you want it, you can have the receive side on 12.5 and the transmit side 12.5, or vice versa. You have this one 25 kilohertz. 25 kilohertz, but I'd choose to go for this demonstration 12.5 and 25 kilohertz. So so when it's transmitting 25 kilohertz, so the audio sounds a little bit louder, a little bit more punchier, but on the receive side it's 12.5. But anyway, that's really irrelevant anyway. It all comes down to how you want to set it up and what's your preference, how you want to set the repeater up. It all comes down to quality and sound too, what you're used to. Anyway, that's the video there, and we'll wrap this one up now.